Okay, this is that SL Amps Clean Custom, which is their version of the Dumble Steel String Stinger, Swinger, whatever. And this amp has a very complicated thing going on with its negative voltage supply, which is what toasted in this particular example. And there was some speculation in the comments about the resistor, not the resistor, sorry, the diode in the bias supply shorting out. The diode is absolutely fine, 1 in 4007, or the capacitor shorting out. The capacitor did fail, but I think it was a push-me-pull-you situation where the 3.3K 3-watt resistor coming from the HT supply to the diode got hot, and the very nearby 85-degree rated FNT got hot as a result. And as the FNT got hot, it got closer to shorting, which pulled more current through the resistor, and they just fueled each other into a situation where the hotter the resistor got, because the more current going through it, the more the capacitor went towards failing until the capacitor spewed its guts and the resistor burned and burned the board. Now, I don't know that that was the entire cause of things. I know that instead of a 3-watt 3.3K resistor, the replacement going in is going to be a 5-watt, and I will mount it off the little eyelet board so that should it fail in the future, it will not char the board again. And I know that rather than having that 85-degree axial cap right next to that resistor, which might get hot, I'm going to install a 105-degree radial capacitor over here on the board. This eyelet right here is functionally equivalent to the connection on the old eyelet board where that cap was. So I can install get a little bit of longer wire here to move this out of the way, and install a radial cap from here to what will be ground when I'm done here. This is not ground at this point, but this is a great place for me to put a radial cap rated for higher temperature. It'll be well away from any resistor that gets hot. This makes sense. There is no axial cap on the market rated for more than 85 degrees when it comes to 450, 500 volt caps. The radial is the better choice. For a number of reasons, will be a better performing capacitor. Now, the Dumble circuit, and this is a copy of it in most regards, has an unusual thing where you have the HT connection, which goes through a 3.3K resistor, and then the diode, and then that on the other side of the diode, you end up with about negative 385 volts DC, has its filter cap. Dumble used a 10 microfarad 450 volt cap. This had a 22 microfarad 500 volt cap. At that point, that negative 385 goes over here, and through these 220K resistors, that provides a reference to the cathodes of this tube, which is a cathode follower. It's a 12BH7. I initially misidentified it at a quick glance as an EL84. I thought maybe they're using EL84 as a reverb driver in this amp. That's before I knew that it was the SSS that they were copying. But this voltage also goes to this 820K resistor, and then in the Dumble it's got 130K to ground. More on that in a moment. And at that junction, where it's much lower than 385 volts DC, it's about negative 40 something. That provides the bias reference for these 1 megs, which feeds the grids of this cathode follower stage. So you have a very high voltage, so to speak, when you're talking about negative 385, providing a reference for the cathodes here, and you've got a negative 40-ish reference for the grids here, and that gives about negative 40 something volts on the grids going to the output tubes. More on that in a moment. Now, on the Dumble, it would have an 820K and then 130K to ground. On this one, it's got 830K 820K to a 170K, but instead of going to ground, it then goes to a 25K linear taper pot wired as a variable resistor to ground. So right now it's about 16K, so 170. This is about 186K. The dumble was just 130K. And this can be varied from 170K to 195K. So this changes the bias. So this is the builder's attempt to put a bias trim pot in this amp. The issue with the way this is done is that changes in this bias will affect this voltage, and that you pretty much want to be fairly constant, I do believe. And it would be very convenient to have ground here for the filter cap from this node. So what I think I'm going to do is, rather than have a resistor here, I'm going to have a wire going from this point to one of the outer lugs of this pot. It will be lug 3. I'll reverse these. When it's wired as variable resistor, it doesn't matter which one you use, 1 or 3. And what we're going to be doing, it will be. So this wire is going to go away. This resistor is going to go away. This wire, which comes into the input of this pot, will be moved to here. And we'll go into the pot, and then we'll have probably 130K, or maybe this same 170K here. I'll play around with that value to see how much of a range I have. And at that point, no matter where this pot is turned, and that other end of that resistor will go to ground, no matter where this pot is turned, this will always have the same resistance to ground. And the connection that goes to here, the bias, will be on the wiper of this pot. So we'll be able to vary the bias to this point while leaving this point stable. And that will be very, very good. And we'll have, at that stable negative 385-ish, we'll have the capacitor going to ground here. And that will make for an improved bias supply. If you're watching this and you're distracted by this burnt resistor here, I addressed that in the previous video, where the builder had swapped these two resistors. They had used the 22K where he meant to use 1.8 and vice versa, and the reverb transformer was nuking this 1.8K. That's going to be addressed. So that puts everything back to how it was and makes a slight improvement to the dual role that negative voltage plays, both as a constant reference here and as a more traditional bias reference here. That does not tell me whether that resistor, that original burnt resistor, just got too hot and snowballed because the cap was too close to it, or whether there is a problem in the amp which will cause too much current draw for any 3.3K in there, even if I put in a 5 watt, which I'm going to do. And if any one of these output tubes has a grid leak or some other error causing it to draw too much current, that could, through the 12BH7, cause the problem at this point. If there's a problem with the 12BH7, it could conceivably cause that. Now, whatever happened to cause that excessive current draw, the HT center tap of this power transformer goes to ground over here through a 500 milliamp fuse. That fuse did not blow. So while the fault that caused all this nastiness blew the 4 amp fuse, it did not blow the 500 milliamp fuse. So there was not significant current through the HT supply when that was happening. It did not trip the 6 amp fuse that the owner put in here either. But the issue is, if this were just a negative voltage that could be affected by current draw, I could fuse this, or I could fuse it after the split to the bias. I could fuse this point. But if I do that and it trips, then the output tubes will have no grid reference, no bias on the grids, and then you have other problems. So I'm wondering whether, in this case, given it's a very expensive amplifier with a very unusual circuit that it inherited from the Dumble that's copying, it might be good to put individual cathode fuses on these output tubes so that if a tube is drawing too much current, that tube shuts off rather than causing potential another fire down the line. So I need to ponder that a bit. There's just not a lot of other good options available other than, putting it back, improving the bias supply a bit, and then crossing your fingers that nothing ever goes wrong. It seems to me a flaw of the Dumble as well, a potential flaw. It's just a potential flaw until something happens. On this amp, it happened. And I don't think it's because, I don't think it didn't happen to Dumble because it said Dumble, and it happened to this because it said SL amps. I think that Dumble and his clients back in the days of yore were using very high quality 6L6s. If you go back to the 70s and 80s when a lot of the myths were formed, these would have had relatively new old stock Sylvanias and GEs and RCAs and stuff in them. And they're just a little less prone to faults than current production tubes. On that note, in addition to some cathode fuses for these output tubes, and it may be complicated by the fact that their half power switch is doing a partial cathode bypass on two of these tubes. That's a deeper subject. I think it might be good to put some diodes from pins 3, the plates of each output tube, to ground, which can also prevent a lot of stuff. Just some flyback diodes. People argue about whether they change the sound. I find that they change the sound a lot less than having fires. So, discuss amongst yourselves.